In this video, we're going to take a look at creating a custom MDL material. Back in Substance Designer 5.3, we added iRay and MDL support. MDL is NVIDIA's material definition language, and it's used to describe how your material will behave. When we integrated MDL and iRay, we recreated the OpenGL shaders as MDL so that it would be seamless when you switch to iRay, you get pretty much the same result. This made it easy to use iRay as you would work on a substance and it would just work in iRay. However, this was limited as you could only use one material layer. You could output the result of the substance, but again, it was only one material layer. So we needed to implement a new dedicated graph to support multi-layered materials, and that is what we have here in Substance Designer 5.5, which is a new MDL material graph. So what does Substance plus MDL bring to the table? For MDL users, Substance allows for exploring new patterns and subtle variations of all the aspects of your materials. For Substance users, MDL allows for exploring new types of materials, multi-layered, more complex effects, and render it in iRay as reference. For both, Substance Designer can become the material hub where a material is defined once and simplified to achieve consistent results in different technologies or products. So now we're going to create a new MDL graph, and we're actually going to just recreate the physically based metal rough shader as an MDL. And this will help, get our feet wet so that we can just understand the overall process. So I have Substance Designer 5.5 loaded up, and then here at the top of the graph, we have a new button here that's going to allow me to just add a new MDL material. So I'm just going to click this, and I get a new MDL graph, and we have a few templates here. So what I'm going to do is just choose this empty, and for the graph name, let's just call this metallic underscore roughness. And we'll click OK. And so now Substance has created this new graph here, which is our MDL graph. And I can navigate in the graph the same as you would the Substance graph itself. However, you'll notice here that we have this material root. Now, with a Substance, we've always had these multiple outputs, but with an MDL, we have just a single output, and that's going to be the material root. So here in the 3D view, we have a mesh, and as you can see, the renderer is set to iRay. So before we start actually creating the graph, I think I'm going to set up my 3D view. I'd like to just use a different mesh. So I'm going to right click the package, and I'm just going to link in a 3D mesh, and I'm going to use this Substance sphere, and we'll load this guy in, and here is the FBX. Let's just double click here, and we'll just load this into our 3D view. Let me come over to my environments, and I'm just going to use this this map here. What I'm actually using here is the Tacoma Studio HDR that ships with Designer. So we'll just drag and drop, place that here into our 3D view. And just a few other things. Let's just come over here to the environment, and I'm just going to set my ground on. And for the visible here, for the display component, I'm just going to set this to false. So here's what we have. And I can just move my light around, and this just kind of gives us a starting point here to work with. Okay, so now we are ready to get started, and here I have my material root node. And so what we're going to do here is I'm going to come over to this input, and I'm going to utilize kind of a new way of creating nodes here. So what I'm going to do is just hold down my left mouse button, and I'm going to drag out a connection line. Now, when I let go of my left mouse button, you'll see that we get this new pop-up. And we can, use the scroll bar to search through, or we can actually use this search here at the top to start to type in. You can also use just the spacebar menu. It's going to give us the same type of search window here that you are accustomed to with Substances. But like I said, we have this new option here where we can just left click, and when I let go of my mouse button. Now, if you use kind of this method, what it's going to do is it's going to actually kind of pre-filter some of these nodes here based on whatever this input needs. This can kind of help you when you're getting started if you need to know what kind of data types are going to work correctly with the input that you're trying to hook into. So what we're going to do to start is I'm going to use this material, this first option here, which is going to give me a material, and you'll see here it's going to give me this material surface. Let me just click it here so we can create the node. And so now that we have the node created, this gives me a material, and this is like the structure here so that we can kind of see things like, well, we have our surface, we have things like our volume. This is where you define how light is absorbed and scattered inside of a volume. And then here we have like our geometry, which is going to handle things like displacement, normal, bump, cutout, opacity. Here I can actually demonstrate what that is now by, if I just go over to this output here, I'm just going to left click, again, drag out a connection line, let go of my left mouse button. And now again, here you can see, like I was saying, these options here that are displayed are kind of these pre-filtered nodes. So what I'm going to choose is this first one here, material geometry, which gives me like a 3-float input. And so here you can see that I got inputs for displacement, cutout, opacity, and normal. Now, just as you would with the substance, we need to view the output of this material here in our 3D view. So I can just right click here and I can choose view in 3D view. Now, right now, we don't actually have a surface or a material surface hooked in, so we're seeing this black here. So let's take care of that now. I need to come up here to this surface input and start to work on the material surface. So here I'm just going to just left click, drag out a line, let go of my mouse button, and the first thing I'm going to choose here is going to be this material surface, which gives me this BSDF. So let's select this node here. This gives me my material surface. Now we need to set the BSDF. So here, let's left click, drag and drop, let go of our button again, and now we get that kind of pre-filtered result. And the first thing I want to do is grab hold of this diffuse reflection BSDF. So let's choose this option. So now when we see this here, we're starting to get a bit of a rendering happening here to our material. Here you can see our post effects is on. Let's turn that off. So let's go to camera, edit selected. And here you'll see post effects. Let's just turn this effects enabled to false. So we'll turn that off. Now, let's go back here to our diffuse reflection node, and you'll see here that we have these properties. And that works just like when you're authoring a substance. You select a node, and then here you can see the properties that you can edit that are associated with that node. So again, we'll go back to diffuse, and here I think what I'll do is just take this value range, and I can, just drag this down. And here we can see that iRay is updating, and you can see that just changing these properties will give you kind of a real-time display of what's happening here to our material. Now, on this diffuse reflection node here, I don't want to just set the tint color like this. I actually want to be able to have this so that it's an exposed parameter. So in order to do that, I'm just going to come over here to this tint color, and I'm going to just, again, same process, left click to create a connection line, let go of my mouse, and then this is going to give me some options. What I'm going to choose here is this color node. And what I'm wanting to do here is create this exposed value so that we can change this color. And so let's first just set the color. So I'm going to pick something like, closer to this kind of like this orange, and I'm going to pull the value down. So we'll get something like this. And like I said, we want this to be like a user-driven parameter. So what we're going to do here is, with the node selected, I'm going to right click and I'm going to choose this exposed option. And so now when I do that, you'll see over here in our properties, and let's just give this a bit more room, we have the ability to kind of work with this exposed parameter. So first thing we want to do is set our gamma type. Now, since this is going to become our base color input, we're going to change that gamma type here to sRGB. Now, we're also going to want to set our sampler usage. This is going to work similar to how we would set a usage for our substance outputs. What we want to do is define an interface here for the MDL so that we can link these substance outputs here into the exposed parameters for our MDL. So, for example, we want to have this tint color. We want this to be our base color. So I'm going to come over to the sampler usage, and I'm going to click my drop down, and I'm just going to choose base color. So now when we hook in a substance output of base color, the MDL is going to know basically what to do with it. So here for the display name, let's just go ahead and call this base color as well. So here we go. We have our first exposed parameter. Now I'm going to just double click an empty spot out here in my graph, which is going to basically take me to the root level. And again, that's the same as if you were working with a substance. And you'll notice here that I have my first input here. So this is our color, and you can see that we can change this now. So here, let's just take it back to kind of like that orange. And again, I'm going to drop my value down. So we'll get something like this here for now. We also have here for our MDL annotations, you can see we have a display name. It's just set to empty. That was the name of the template that I chose. So here, let's just call this metal rough underscore MDL, just so we have just a different name to that. Okay, so here you can see that we have our diffuse reflection. Let's just select these nodes and just kind of move this guy a bit out of the way here so we can start to get a better visual representation of how we're working with this here. So we have our material root. Here we have our material structure. This is where we're going to start building out our material surface. Here's where we're going to work with our geometry, like displacement and normal. And then here's where we're starting to build, our diffuse reflection. So this is like, again, what we're doing, our base color or albedo. So the next step is going to be to add our specular layer. So we're going to add this on top. And so what we're going to do here, in this case, I'm just going to hit the space bar. And in the search field, I'm going to start to type GGX. And I'm going to have these two options here. And I'm going to choose the first one. And the first one here is going to be GGX Smith. So we're going to use this BSDF. And so here we have a node. And before we keep going, let's save what we have. So I'm just going to save this substance really quick. So tutorial, we're just going to call it Metal Rough SBS. And now we have this guy saved. Okay, so now we have, again, here's our diffuse reflection. And now we have this GGX specular BSDF here on top. And we're going to combine these two layers. Now, there's two ways to combine layers. Let's look at the first way here. So I'm going to hit the space bar. And I'm going to start to type in Fresnel. And I'm going to use this option here. It's our second option. You can see that's Fresnel layer. And it's going to have some inputs like color, float, BSDF, and so on. Let's use this one. So I'm going to select this node. And you can see what this creates for me. Let's just kind of zoom in so we get a really clear visual here. We've got two inputs. We've got a base BSDF. We have a layer and then an IOR value. And we're going to use this guy here because it's basically going to allow us to take like a base layer and then just put another layer on top of that. Another way to work with this is that we can actually mix BSDFs together. And this is more like kind of traditional blending with like a mask. Now I'm saying the term here BSDF, and what I'm talking about here is just, one specific piece of an algorithm that defines how light behaves. And we're also talking about the ability to have horizontal and vertical blending. But here in this case, we're just going to take our base layer, which is our diffuse. I'm going to plug that in. And then here we're going to have our specular, and we're going to plug this in here to the layer. So now we have these two guys in place. We need to set up our IOR for this. So let's take a look at a couple examples on how this works. So what I want to be able to do is just supply an IOR value to this. So here what I'm going to do is just drag out my connection line, let go of my mouse button here, and you'll notice here that, we have a node here called IOR float. So if I choose this here, you can see that, this gives me an IOR value, a default of 1.5, which is, what we default to with Iray. So I have this node, but this node, I'm just going to caution you that it may or may not actually be in the final build of Designer. The reason being is that if you export or save out your MDL utilizing this node, it does this link back to our library, and it's not as encapsulated as we would like it to be. So I just wanted to let you know of this because I think they're still on the fence on whether this node is going to make it into the library or not. So it's here. You can see how this works, and this will actually work for us. So if I just come over and I just take this connection and plug this in now, you can see that, here we are. We start to have our specular level here. But I just kind of want to show you what I'll refer to as a safer way to kind of do this. So here, I'm just going to hit the space bar, and I'm going to start to type in float. And, here we have a float node. Let's choose this guy here. Now, for this float, what I can do is just come into the value here. Let's just double-click to enter a numeric field, and let's type in the 1.5 as well. So now I have a float value, and you can see that, this is still just a float as well. So here, let's just select this connection line and delete it. And let's take our output and just plug it right into this IOR. So it looks like it's not going to, be the same data type. So as soon as I pull this connection into place here, you can see that Substance Designer has created, this color node. So it's docked, so I can hit the D key on the keyboard to undock that. And you can see here that this has created a color node for me. And so what we have here is just, the same exact effect. So I plug this in, you can see this is the IOR value. Here is what we have here with the color. So we can actually work this way. And like I said, I think this is going to be the safer way to work. So let's not use that IOR. I just wanted to bring that to your attention in case you do see that in our library. Just know that, again, when you publish your substance, when you publish your MDL, it's just not going to be as encapsulated as it's going to link back to our ALG library. Whereas using this route here, it's going to keep everything kind of encapsulated into the MDL, which is better. Okay, so now that we've kind of just defined that, again, you notice that we can select a node and hit D to kind of dock it, just as we did in Substance when we were working in Substance Graph itself. So let's take a look at what we have so far. Now, we just kind of clean things up here visually, so everything's going to make a little bit more sense. So the first thing we did here was we created our diffuse reflection. Then we added specular on top of this here. And then we were able to blend the specular on top using this Fresnel layer. So we have our base, which is our diffuse reflection. The layer is going to be our GGX BSDF that we've added into here. And then we just plugged in this IOR value here. Okay, so right now we're still kind of working on this as a dielectric material, but we actually need to add some controls here for our roughness. So let's come back over to here to this GGX BSDF, and you'll notice that we have two inputs here for roughness. We have U and V, which is basically going to be horizontal and vertical, and these are split so that we can create anisotropic type effects. So here I hit my space bar, I'm going to type in, or start to type in float, and so here we have this float value. Now, what I can do with this here is just take this guy and just plug it into both the U and V. So now I have this float control, and as I start to increase this here, you can see that now we have a control here for our roughness. So one thing that we want to do here, again, we're just trying to recreate that physically based metal rough shader that we have, is we actually want to square this float value, because that's what we do in the shader. So there's a lot of other operators and functions that we have for this MDL graph. So if I hit the space bar here, you'll notice that, well, here at the top, we have these operators, and I'm just going to use this multiply operator. And so here what I'm going to do is just plug this float into the X and Y, and then take my output, and again, just put this into the U and V. And so here's what I get. And now this is more in line with what we're actually doing in the physically based shader. So we're just squaring that roughness. So we have our control here, but as we did with our base color, we want this to be an input. So here we'll have this selected, this node, and we'll right click and choose exposed. So now we're going to come over and set our gamma type. So since this is roughness, we want this to be linear. And then again, we just need to set our sampler usage. And we want to make sure that this lines up correctly, so we need to use roughness. And for the display name, let's just type roughness. So double click to get to our root level, and now you can see that we've got our base color, and we also have this cool roughness slider here. And you can see how that's working. So at this point, like I said, we have our diffuse reflection. Here is our specular component here, and we're blending these two guys. We're doing that using this Fresnel layer. And right now, we're just using this default IOR value here at 1.5. So the next component or FX we want to add to our graph here is going to be metallic. So here's how we're going to do this. Let's just make a little bit more room here. What we need to do is we need to blend two BSDFs together. So what I'm going to do is I'm going to hit my space bar here, and I'm going to do a search here for a node, and it's called the directional factor. So I start to type in directional, and you'll notice here's the node that we have, directional factor, and it has color, float, and BSDF as input. So let's select this guy, and so here you'll notice that we have this BSDF, and then we have these two input options here. So if we look at this, you'll notice that we have normal tint and grazing tint. And what this means by normal is that it's basically, what we are looking, directly at. This is our F0 value here. And since we're talking about a metallic, what this is going to represent is, that base metal reflectance value at F0. And then it's going to have a grazing tint value here, which is going to go all the way to white, which is going to be just pure specular at that point, or reflectivity on the edge, we'll say. So let's first create our pure specular for our metallic. So what I'm going to do here is just come back over to our specular component here, and I'm going to grab the output, so it's a BSDF, and we're going to plug that into the BSDF input of our directional factor. And so, here's what we have at this point. So just so that we can get an idea of what this is, let's take this output. We're going to bypass our Fresnel layer here at this point. We're just going to plug that right into our material surface. And you can see what we're getting is, like I mentioned, this is going to be our pure specular here for our metallic. However, at this point, we don't have our tint. So with like a metallic, the base metal reflectance value is going to be tinted. Now, we want to pull that from our base color. So here we have our base color. So let's just take the output here and just plug that all the way here at the top where we have our normal tint color. So let me just zoom in so you can see where we made that connection on that node. And here you can see that, well, this is starting to look somewhat metallic here now. So this is going to be, again, our F0 value here at our normal tint. For our grazing tint, you can see that that's set here to white, so that's going to move towards 100% reflective. And then we have this option here for this exponent, and it's set to 5 by default. So what I'm going to do is I'm going to change this here to a value of 3, because this is what we actually use in the physically based metal rough shader here in Substance. So now we have this set up very similar to what we're doing in our shader. So that becomes our directional factor, which again is going to represent here our metallic. So let's just do a little bit of organization here on the tree structure or the node structure here so that we can start to really see what's happening. So if we look at it right now, like I said, this is our directional factor, this is our metallic, and then we had our Fresnel. So let's take our Fresnel and plug this into our material surface, and you'll notice that, okay, now we get our dielectric. So the Fresnel layer, which is going to be a combination here of our GGX BSDF and our diffuse reflection, that's going to give us our kind of dielectric material. And then here we have our directional factor node, which if we plug this in, it's going to give us our metallic. So now we need to create a way to blend between these two guys. And we can do that by using what's referred to as a weighted layer. So to do this, I'm just going to hit my space bar here, and I'll start to type in weighted layer. And you'll see, well, we got these 3 nodes so far. The one that we want is going to be this middle one. And notice it says weighted layer, and the inputs here, we've got float, BSDF, and so on. So we want to use this second option here. And so when I plug this guy in, you can see that we get, a base and a layer. So like I said, we've got our directional factor. This is our metal. So let's put this on top. And then here, this Fresnel layer, which again, just to show it, represents our dielectric. Let's put this on the bottom. This is going to be the base BSDF. And then I'm going to plug this output of this weighted layer here into my material surface. All right, so again, just a little cleanup just so that we can make sure this is nice and clear as we start to work here. So if we look, we've got our diffuse reflection. This is our specular component. Here at the Fresnel layer, where we're mixing these two guys together here, that's going to become our dielectric. And then here at the top, we have our directional factor, which is going to be our metallic. And we have that set because that F0 value is linking back here to our base color. So we have that working, but we need to have a way to be able to mix these guys together. Well, if we come up over here to the very top of this weighted layer, you'll see, well, we do have this float value here, but I actually want to expose this as an input. Well, I can do that by just clicking this button here. Now, notice at the top we have these 2 buttons. And this one here is just going to copy value to a new node and link the parameter. And the second button here is going to, this is actually what we want. This guy is going to create an input pin for this specific parameter. So notice right now we don't have an input pin. So let's click the button, and now we have our input pin. So what we need to do is just create a float here. So hit the space bar. And I'm going to start to type float, and here we have our float, and let's just plug this guy here into the input. So now if we go back to this float and I set this up to 1, we get metallic, and at 0, we get the dielectric. So of course we would want to take this now and expose this value. So take the node selected, right click, choose exposed, and here for the gamma type, very important, we need to make sure we set that to linear because it represents data. For our sampler usage, we want to make sure that we hook up the interface correctly between the substance and the MDL. So here we just select the drop down and we choose metallic, and it's in here somewhere. Just a hint as well, like see how I'm trying to search through this and I found it here at the bottom. You can also input text into these. So notice that if I start to type metallic, it's just going to show up. So that's just kind of a quick tip on how to set that sampler usage. So here I'll just copy that name, and for the display name, I'll just paste it into here and just keep that, uppercase M, I guess. Okay, so let's just kind of just double click to go to our root level. And here we can see we're just checking our inputs. We've got our base color, our roughness, and our metallic now. Moving on, another thing that we would probably like to implement with this is the specular level control. So with our physically based shader, we have a specular level input for the metallic rough variation of that. And what that allows you to do is, set a custom IOR value basically for the dielectric. So with the metal rough shader, the dielectric reflectance value at 4% is hard-coded in the shader. However, we supply a specular level input that allows you to modify that. And again, this is only for the metal rough shader. So let's go ahead and implement that now. And by doing so, we're going to utilize some new nodes. This is where we have our metal, and this is where we have basically handling our dielectric component here for that part of this material. I want to replace this by an actual value that we can change. So to do that, I'm going to utilize a node, hit the space bar, and I'm going to do a search for the custom curve. So we'll start to look at that, and here you'll see that we get this custom curve layer. And here I'm going to choose this second option, which is going to give me the inputs. And so you can see I have it selected here or highlighted so you can see what that name is. And so we'll select this custom curve. And with this guy in place, I'm going to do the same thing. So if we look up here at the very top, we've got this normal reflectivity float. And what this is talking about is, viewing like straight on down the normal. So this is, again, our F0 component. And so we want to expose this, or actually create it as an input here that we can use. So what I'm going to do is come over and I'm going to click that middle button again, which is going to create that input pin for me. And so now I have a float value. So here, what we'd like to do is end up replacing what we have here, this Fresnel layer. And instead of using the Fresnel layer, it's basically the same thing that we're doing, we're just creating a custom curve of this. So again, you can see that we have a base and a layer, and in the Fresnel layer, it's utilizing this IOR. However, what we're going to do is set this up to be kind of a custom setup where we're going to have our base, our layer, and then we're going to create a user value that we can drive this dielectric F0 value. So let's do that now. So we're going to take our BSDF here, our GGX BSDF, and we're going to plug that into the layer. And then our diffuse reflection here is going to be our base. So here's what we have. Now we want to start to work here with our float value. So what I'm going to do, let's just grab this guy that we already have. And I'm just going to set this here. Here, let's do this. Let's take this custom layer. Let's take its output, and we're going to plug this into the base here of our weighted layer. So like I said, the idea is that, we're getting rid of this Fresnel. So let me just select this node and just delete it. Okay, we're just going to get rid of that altogether. And let me just delete that color node that we had. All right, and let's bring this guy down, just making things kind of nice and visual here so we get a clear representation of what's happening with these nodes. Okay, so we have our custom layer here, and like I said, we want to drive this with a custom dielectric value. So the first thing we need to set is that F0 value for our dielectric, and that's what this normal reflectivity input is going to be. So let's just reuse this float that we have. Now for the default value, what I want to do, I'm just going to double click this guy, and I'm going to type in 0.04. And what that's going to equate to is 4% reflective. So we're entering this in as a linear value, and this is going to be, or what this float represents is the linear value, I'll say. And this equates to, like I said, 4% reflective, what is typically hard-coded into the shader. Or I'll say it is hard-coded into the shader unless you're using Specular Level. So let's take this output and plug it right here into our normal reflectivity input. And here you'll notice that, well, we get the same look that we had when we were using that Fresnel layer here with the 1.5 IOR. So here we basically have the same setup of metal rough shader that has a hard-coded 4% reflective value, that F0 value for dielectrics. But like I said, we really want this to be a user-defined parameter. So the next thing that we're going to do is just create a few other nodes here. So I'm going to hit my space bar, and I'm going to need this operator node. So this actually multiply. So we're going to need that, and I'm going to need another float. So I'll hit my space bar again. I'll start to type in float, and we'll create this float node. All right, so let's just rearrange this just a little bit here. Okay, so what we do in the actual physically based shader is that when you look at the range of the dielectric F0 value, okay, so like I said, we have 4%, which is the default. It's going to range in the shader from 0, which represents air, all the way up to 0.08 or 8%, which is like going to represent things like gemstones and such. And that's the range that the shader remaps to when it comes to this specular level. So we got 0 all the way up to 8% or 0.08. And we need to represent that here. So what I'm going to do is go back to my float here, and I'm going to change this from 4% to 8%. So that would be 0.08. So that's going to be like the high range of this here, okay? Now, let's just take that value and plug it here into the multiply operator. So now we've got this float, and this is going to become the control that we use. For the specular level, we want that to go all the way from 0 to 1. That's kind of the range of what this control is going to be. And at 0, we want it to be, well, it's going to be 0. And at 1, we want it to be this 0.08. So by using this multiply operator like this, we can accomplish that. So I'll plug that guy into here. All right, so now let's take the result of this operator and plug that here into the normal reflectivity. Okay, so here you can see we're still getting the same effect. However, the default value for this float is we want it to be actually just 0.5. And so when we do that, when we set that to 0.5, what that's going to do is basically put that at 4%. So again, that's how the shader works. If you've checked out our PBR guide, that's denoted there in our PBR guide that the shader is remapped at 0 to represent air, at 0.5 is actually going to equal 4%, and then all the way here at 1, it's going to equal this 8%. And that's why we have this float here at the max value. So what we're doing is we're giving ourselves this range to go from 0 to, here at the middle, we've got 4%, and then here at the high end of the spectrum at 1, we've got 8%. So let's go ahead and set this down here to 5. Now, another thing that I want to do here for this custom layer, just like we did with that Fresnel layer, we want to set that exponent value to be, what we actually have it set to in our shader. So I'm going to change that from 5 to 3. Okay, so like I said, that takes care of adding this specular level control. However, we need to expose the parameter, so we're not quite done yet. So let's select the node, let's right-click, choose exposed. And for the gamma type, very important, we need to set that to linear. And for our sampler usage, here I'm just going to start to type in specular. Well, this one, I have to type the whole thing out. I might as well just search for it. So it's right there. Choose specular level. Let's just copy the name, and for the display name, we'll just paste it in. And there we go. It's going to take care of our specular level. So I'll double click, and now we're going to look at our inputs to our MDL. We've got base color, rough, metal, and our specular level at 0.5, which is going to default to a value of 4% for that dielectric. Okay, so the last thing that we want to do here is fix or hook in our input for our normal. And so now we're going to come back over here to our material geometry node that we have. And here we have our normal. So what I'm going to do is just take a connection line out here and just let go of my mouse button. And I'm going to choose float 3 node here. And then what I'm going to do for this guy is I'm just going to right click and I'm going to expose this. All right. And so for our gamma type, we're going to set this here to linear, and our usage, this is going to be our normal here. Let's just search. Let's just type it in. So here's our normal. And then here for the display name, I'll just type normal. Okay. So that takes care of our normal so far. We do need to add just one more component to that here. So let's just kind of get things kind of cleaned up a little bit visually. Okay, so one of the things that we need to do with this is that we have a concept of states here inside of an MDL. So I'm just going to pull off a connection line here, let go of my mouse button. And for this, well, here, let's just start to filter it even further. I'm going to start to look for normal. And so here you can see that we have this normal node here, which is going to be the state normal of the geometry. And so I'm just going to use this guy here to start with this. Now, we need this as like a default value, because you'll notice that when we created that normal, its default value was just 0, 0, 0. So that's why we're going to use this normal state of the geometry here. If we come back here, let's do this. Double click to go to the root level of our graph. You'll notice that we have normal, but something's already plugged into it. What this is going to allow us to do is it's going to give us an input, because we're actually going to drive the value of our normal based on a texture input. And so using this normal state here is going to allow us just to have, just a default value to begin. All right, so we'll just kind of zoom out on our graph here, and let's just take, just another kind of quick overview of what's kind of been happening here, just so that we can get a really good idea here. So what we're going to do is, let's do this. Let's take our diffuse reflection here, And I'm just going to add just, I got this node selected here, and I'm just going to add, just a frame to this guy. And so for this frame, we can call this is going to be our diffuse reflection. And let's select these nodes here. So again, that's our roughness. Here, we'll pull this guy out here. Here is, this is our GGX kind of BSDF that we were using here. Let's get this node selected, and I will create a frame for this. And for this frame here, we'll call this spec reflect. So we can kind of see what that is here. I'm going to select this node here and add a frame for this. Now, this here is going to be where I'll just label this as dielectric. So you can see kind of where that's happening, where we're blending that together. Here, this is our directional factor that we use to generate our metallic. So we'll come in here and call this metal. And let's just grab these guys and just move them down here a little bit. Let's select these nodes here at the bottom. Let's do a frame for this. And here we'll call this normal. And these are going to be our inputs, basically. So here we'll do a frame for this. And for these, we'll just set them to, just a different color here. And for the frame, this is going to be spec level. Here's our roughness. I'll just label this guy roughness. And this last one we'll do here, this is going to be our metallic. Just again, we'll set the frame color, and we'll just call this metallic. Okay, so now when we kind of just back out and take an overall kind of view of what we've built here with this MDL, we can get kind of a more clear kind of visual representation here. Actually, one more. Let's do this guy because we want to just colorize this guy, and we'll call this base color. There we go. So yeah, here when we look at everything, we can see that, well, we've got roughness input, base color, spec level, and metallic. Here is our normal. This is where we're kind of handling our normal. Here is where we have our diffuse reflection, our specular component. We're blending those guys here using this weighted layer here, and this is where we're getting the dielectric. Then here we use this directional factor to create our normal, or excuse me, our metallic specular. And then we're blending those two guys together with a weighted layer. So here's our metal and our dielectric that's getting blended here. And that's driven by our metallic float here, our metallic input. And so now we've just recreated that physically based metal rough shader here using an actual MDL material. So at this stage, we've been able to create the MDL graph, and we've been able to expose our parameters as shown here. But it's only parameters at this stage. These parameters can be converted to input samplers on the fly. So we can plug textures in, and more importantly, we can plug substance inputs into these parameters. So now I'm going to show you how that works. So to demonstrate that, let's just come over to our package. This time I'm just going to right click and choose New MDL Material. And here for this, we'll leave it as empty, and we'll just leave it at the default name for now. So here's our MDL, and we have our root. What I'm going to do is take this metallic roughness MDL that we've been working on, and let's just drag and drop to instance it into this graph. And now we'll just make the connection output. And so here's what we get. We've got our MDL rendering here in our 3D view. So like I said, now we have our inputs here. If we wanted to, we can come over and we could start to, adjust things. Like here I'm adjusting our roughness, and I could change color, adjust metallic, and so on. But like I said, these are inputs, and we can drive these inputs with a substance. So let's do that by just here in the PBR materials, I just have bricks. Let's just grab this bricks and drag and drop and place this guy in. And so now what we can do is take the outputs from our substance, and we can plug these here into the inputs or the parameters that we set. I'll say the exposed parameters that we created on our MDL. And like I said, that's going to create sampler inputs on the fly here. So just so we can see this, I'm going to take my renderer and I'm just going to pause it here, and we'll go to base color and let's plug it in. Next we need our roughness. So here's our roughness. We'll plug that in. Metallic, plug that in. We don't have a specular level. Here's something that we could do. So I have the node selected, and well, we don't have a specular level. We don't need that. So what I can do is come over to the specular level here, and I can just click this button here to remove this input. So I'll click this here, and now it's no longer available to me. I don't have to worry about it. So the next thing here is our normal, and let's grab our normal and just plug this in. Now, you don't have to remove that. You don't have to remove that parameter. It's still available, but what I did was I just removed it from the input here, so it just gives me kind of a cleaner setup here when I'm doing my connections. And so now I've made that connection. Everything's going to my material root. Let's go back to our renderer, and now we'll just hit resume rendering. And so here's what we get so far. We can come back here to the substance here in this MDL graph, and you'll notice that, well, we have all of the parameters available to us for the substance, and we can change the resolution size if we want. We also have the ability to change the tiling. So I'm going to come over here and set this tiling to something like, say, 4. And so here we've created a physically based metal rough MDL, and we're supplying substances to drive the inputs. The MDL itself is used to define the complex material behavior, and then we have the ability to allow the substance to handle all of the texturing part of it. So once we have everything put together, what I can do is then just save this. So if I come over here to my substance package and I right click, I can choose to export the MDL module. So here we'll choose this, and then here we get this dialog that just allows us to choose the location where we want to save this. Notice that the type is being set as an NVIDIA material definition language. So we're going to get a .mdl from this. And in my case, I'm just going to throw this on the desktop, and I'll click save. And we get a dialog that lets us know that, hey, this save went okay. So I'll click OK to that, and let's take a look at the contents of that folder. So here you can see that, well, the MDL was generated and the resources that we use, because in our particular case, what we're doing here is we had the substance, which is going to be driving the parameters for our MDL, and those get exported as resources. So here we have the textures to those. You can see that I have my roughness, my metal, my base color, and my normal, which again are the maps that were input here to the MDL parameter. So now we can take this here and we could use this MDL within another application that supports iRay, such as the iRay for Maya or iRay for 3ds Max. And that's something we'll cover in another video.